Hello, I would like to talk about chemical equilibrium with the experiment disturbing a chemical equilibrium in focus. So in this experiment we use the homogeneous chemical equilibrium where iron-free ions react with thiocyanate ions to create the complex iron-free thiocyanate, as it can be seen here. So it's very important to this experiment that the product is dark red. And it's useful in order to investigate the chemical equilibrium. Because in the experiment we applied stress to the equilibrium in many ways. When we applied stress to the reaction, this color will show if the equilibrium system shifted to the products or to the reactants to re-establish chemical equilibrium. So if the equilibrium shifted to the left, the solution would become less red, and if the equilibrium shifted to the right, the solution would become dark red. And now I'm going to explain chemical equilibrium. What is chemical equilibrium? Chemical equilibrium is when there is a forward reaction and a reverse reaction. There is a balance between these two reactions, meaning that the reaction rates of the forward and the reverse reactions are equal. This balance can be described by the equilibrium expression. So the equilibrium expression can be seen here, and the equilibrium constant K can be found by the equilibrium expression. So it's the concentration of the product divided by the concentration of the reactants. This quotient down here is called the reaction quotient Q. The reaction quotient must result in the equilibrium constant for there to be a balanced chemical equilibrium. And the chemical equilibrium in this experiment can be demonstrated with this figure to the right. This figure shows the chemical equilibrium in the experiment, and as it can be seen, the reactants are on the left side and the product on the right side, so they are both present. And the reactants react to form the product on the right side, the complex iron-free thiocyanate, and at the same time the product reacts to form the two reactants iron-free ions and thiocyanate ions. And this happens at the same time. So it shows that the rate of reaction of the forward reaction and the reverse reaction is the same. Now I will briefly explain what Le Chatelier's principle is. So the principle can be used to predict the effect of a change in conditions on a chemical equilibrium. It says, if a dynamic equilibrium is disturbed by changing the conditions, the position of equilibrium moves to counteract the change. Now I'm going to present my results. So we distributed the solution into 6 test tubes, and now I will explain the results we saw when we applied stress to each of the test tubes. So in test tube 1 we added iron-free ions in the form of iron-free nitrate to the chemical equilibrium. The color of the solution changed to a darker red color. And in test tube 2 we added vitamin C to the chemical equilibrium, and we observed that the color of the solution turned less red. In test tube 3 we added thiocyanate ions in the form of potassium thiocyanate to the solution. The color of the solution changed to a darker red. And in test tube 4 we added silver nitrate to the solution, and the color of the solution turned white. And in test tube 5 and 6 we increased and decreased the temperature. So in test tube 5 we increased the temperature and we observed that the solution became lighter red. And in test tube 6 we did the opposite. We decreased the temperature and the solution became darker red. And it can all be seen on this picture. Now I'm going to explain why I got the results I got for each test tube. So in test tube 1, we added iron-free ions to the solution. If we look at the reaction quotient Q, we can see that the quotient becomes smaller than K when the reactant is increased. Therefore, the reaction to the right must happen for re-establishing the equilibrium. It also fits to the color change we saw, and to Le Chatelier's principle, because after the change of condition, the position of equilibrium moves to counteract the change. And now if we look at test tube 2, there we added vitamin C to the solution. Vitamin C reacts with iron-free ions, so there becomes less reactant compared to the product. The reaction quotient Q must therefore become larger than K, because of the reactant is decreased. Therefore, the reaction to the left must happen for re-establishing the equilibrium. This also fits to the color change we saw, which was a lighter red color, and it fits to Le Chatelier's principle, because after the change of condition, the position of equilibrium moves to counteract the change. And in this case, it's the reaction to the left that must happen. So now we look at test tube 3, where we added thiocyanate ions to the solution, so there becomes more reactant compared to product. The reactant quotient Q becomes smaller than K when the reactant is increased. Therefore, the reaction to the right must happen for re-establishing the equilibrium. This fits to the color change we saw, which was a darker red color. It also fits with Le Chatelier's principle, because after the change of condition, the position of equilibrium moves to counteract the change. And in this case, it's the reaction to the right that must happen. Then I'm going to look at test tube 4, where we added silver nitrate ions. The silver 1 ions from the silver nitrate reacts with the thiocyanate ions to create silver thiocyanate, which is the white precipitate we can see. Even though we can't see on the color which way the equilibrium shifted, we can calculate it, because there becomes less thiocyanate ions. So there becomes less reactant compared to product. The reaction quotient Q becomes larger than K when the reactant is decreased. Therefore, the reaction to the left must happen for re-establishing the equilibrium. This must fit also for the Le Chatelier's principle, because again, after the change of condition, the position of equilibrium moves to counteract the change. So now I look at test tube 5 and 6. In test tube 5 we increase the temperature of the solution, and in test tube 6 we decrease the temperature. The reaction is an endothermic to the left and is an exothermic reaction to the right. So when the solution's temperature was increased, the endothermic reaction will take place more often to restore chemical equilibrium, which is the reaction to the left. And when the solution's temperature was decreased, the exothermic reaction will take place more often to restore chemical equilibrium, which is the reaction to the right. It's the equilibrium constant K and not the reaction quotient Q in the instant the stress is performed that changes. This fits with the color change we saw, which was a lighter red color for test tube 5 and a dark red color for test tube 6. It again also matches up with Le Chatelier's principle, because after the change of condition, the position of equilibrium moves to counteract the change. Thank you.